welcome to another video. Today I want to talk about ACNS, the Advanced Container Networking Services in AKS. These services will allow us to have additional features and tools for networking like mTLS, we're going to have eBPF, and we're also going to speed up our network connections. This is a bit of a follow-up for the video last time where I gave you an introduction about the Cilium data plane, and now we're going to build on top of this and have even more features. The plan is I'm going to give you a very quick introduction into the advanced container networking services, and then we'll spend most of the time in a demo. As always, if you're interested in the slides or the code, you can scan the QR code or you'll find the link down in the description. Now let's talk about the advanced container networking services. What's important is that it needs the Azure CNI powered by Cilium underneath it. Without that, you can't activate it. If you're interested in the Azure CNI powered by Cilium, I will link the video I did last time where you can see an overview of how it works and how to enable it. What's also important is compared to the Azure CNI powered by Cilium, this is a paid service. This means you have to pay per node in your cluster. I think it's around $50 per month per node. So it's not the most expensive service, but also something you have to consider when activating it. Here you can see an overview of the ACNS features and what you get with it compared to only the Cilium CNI. Here you get mostly the advanced features, for example, FQDN filtering. This means today we're going to see in the demo how we can filter outgoing traffic based on URLs. We can also have level 7 network policies. This means we can restrict our, for example, HTTP verbs we can use. So for example, you can restrict only to use a get or a post, and also what path our requests are allowed to use. And then we also have some encryption, like with WireGuard, we have encryption between nodes. We're going to see later mTLS. This means we have encryption between our pods. And we also have better networking between the nodes. This means we'll bypass some of the CPU limitations, and therefore we'll see that we can speed up the transfer rate. Also, what's very important is that, in my opinion, networking in Kubernetes is one of the most complicated topics, and we are only scratching the surface today. There's so much more to uncover, and I just want to give you an overview of some of the features, maybe something that's interesting for you so you can dive in deeper. But keep in mind, it's nowhere a deep dive today. So with all of this said, let's switch over to terminal and let's create our first AKS cluster, and then let's start with the demo. All right, here in the terminal, let's define a couple variables. That's the name of my AKS cluster, the location, and the resource group. And you can see we have here a second name for a second AKS cluster because there are some incompatibilities, and therefore we will create a second cluster, and I will tell you all about it once we reach that point. Then we're also going to use two namespaces. So one namespace for the front end, one for the back end. And that's everything we need to set up. Before we can get started with the ACNS, we also have to enable it in our CLI because some of the features are still preview. So to do this, we add the extension AKS preview, and with the upgrade parameter, we upgrade it in case you already have it, and if there's a new version. There you can see I already have the latest version. Then we're also going to register the feature in Azure. It's called the Microsoft Container Service, and the name we are registering there is the Advanced Networking mTLS preview. Lastly, we register the provider Microsoft Container Service. You usually already have this in a subscription, and that's also something you only have to do once, but just in case, we're activating it, and then we can check if it's registered. So you can do an AC provider show with the name we just provided, and we query the registration state. Here we can see it's registered. If it says for you registering or not registered, then you either have to register it or just wait a couple minutes until it is fully set up. Now, if this is out of the way, we can create our resource group, and then we're going to deploy everything inside this resource group. So now we're going to deploy two AKS clusters. So the first one, we have the code here. What's important is that I'm using here mTLS. This means this cluster will support mTLS. And I use the no wait parameter, so I can just create it and we can continue with the next cluster. And there we're going to take a look at all the details, how to configure it. Now let me paste the code for the second cluster. That's our main cluster. And here you can see how we can enable ACNS. The first thing, what's important is that we have to use Linux. So either Ubuntu 24.04 or newer or Azure Linux. Then we have the network plugin to Azure. That's already used by default, but I just want to make it obvious what we're using. Then we're using the network data plane Cilium. That's what we did last time with the Azure CNI powered by Cilium. And then we enable ACNS and some additional ACNS features. So first, we just use enable ACNS. Then we enable the advanced network policies. There we can either say none, we can have FQDN, full qualified domain name, or L7. So L7 is a subset of FQDN and it allows us to have the names. This means, for example, DNS names, but also paths and verbs. So we can say, I only want to allow a get, a HTTP get to a specific path. Then we enable the data path acceleration. We use eBPF WEF. This will allow us to have faster transfer rates between nodes, which we're going to see later in a demo. And lastly, I enable the Azure Monitor Matrix. This will set up a managed Prometheus and will also give us Grafana dashboards. And there you can see what ACNS brings, so we have better observability in our cluster. The cluster is being created now. What we can see here is that a couple of features are in preview. So the network policies and the acceleration mode are in preview. And the reason why we are using mTLS in a different cluster is because the network policies have to be set to none. We can't set the network policies to L7 and use mTLS right now because the features are still in preview and they just don't work at the moment. Therefore, we're using a second cluster for the demo. For now, the cluster is being created, so I'm going to stop the video and we'll continue once the cluster is finished setting up. The AKS cluster has been created, so now we can download the credentials and can get started with the demo. The first thing I'm going to do is I'm going to apply the Prometheus config map. That's a config map that's provided by Microsoft for Prometheus. And if I open the file, we can take a look that I only added one parameter. So if you search for Hubble, we can find it here on line 47, the network observability Hubble, and I added this value Hubble.wildcard. This will allow us to collect Hubble matrix and we'll see them in Prometheus, which means we'll see them in our Grafana dashboard. Hubble is used for the observability and it's one of the tools that ACNS installs. It's an, I'm pretty sure, open source tool which has its own CLI. But with this, we don't have to mess around with an additional CLI. We can just see what's going on in the Grafana dashboard. I'm also going to mention this later once we see the dashboard, if I don't forget. But now let's switch back to our terminal. Let's create two namespaces. That's the one for our frontend and our backend. Then we're going to deploy one test container in the frontend namespace. It's just a container for curl, so we'll use this to send requests. And once we have the network policies, we'll see if the requests work or don't work. Next, just to make sure that the container is running, you can see conditions are met, and the condition was that the container or the pod has to be ready. So that's all good. And one last thing is we're going to check that the Hubble pod is running. That's in the kube system namespace because it's installed by Azure when we created the cluster. Here you can see we have our Hubble relay. So that's the container that's going to collect the matrix and then sends it to Prometheus. Or to be more precise, Prometheus is scrapping it from there. So now with all of this set up, let's create our first Cilium network policy. So I'm going to paste it, then we're going to take a look what it does. So you can see it's a Cilium network policy. We're going to deploy it in the frontend namespace. And what we want to do is we want to block every external traffic except to github.com. In the last video, I did the same, but there we had to use the IP address of GitHub. And now we're using the domain name. So what we allow here for the egress is we allow the communication to all pods in the namespace kube system and for the kube DNS. Then we allow it on port 53. That's the DNS port. And we allow DNS rules for all of these github.com patterns. What we can see here is we have a match name. So that's the exact name of github.com. And with the match pattern for the wildcard.github.com. And since we're using curl, which is Alpine based, we need this ACNS workaround. So that's a way how the DNS inside AKS works. And without this, it wouldn't be able to figure out what the IP address of github.com is. So that's a current limitation of the preview. It's documented. When you watch the video, maybe this is not necessary anymore, but you'll see it in the documentation. Then we allow here the access to github.com and everything of the wildcard.github.com, and we allow it only on port 443. This means over HTTPS. Then we're going to apply this. And now we can test if we can access github.com. To do this, we're using our frontend container. We use a curl to github.com, and then we paste the HTTP code. And here we can see we got HTTP 200. This means we were able to access github.com. If we try something else, for example, we try to access example.com, then now nothing is happening because we configured here a timeout of 5 seconds. And since the network policy is blocking this request, it will time out after the 5 seconds, as you can see here. After 5 seconds timed out and the request terminated. And this proves that we were able to block all external communication except to github.com. And this also shows that with the FQDN, it's a better approach than using IP addresses because IPs might change, especially for big websites like GitHub. But if you have the DNS name, this is not going to change. All right, so next up, we're going to take a look how we can restrict or filter by HTTP methods. First, I'm going to delete the Cilium network policy we just created, just to make sure that we don't interfere with each other. So this is gone. Then I'm going to start a second pod. This one is running Nginx, and I use it as my backend. Therefore, I deploy it in the backend namespace, and I also create a service so I can access it. Then we're going to take a look if it's running. So the pod is running, and now I can try to access it. To do this, I send again a curl from our frontend to our backend, and I just use the root path. Then again, I paste or I print the HTTP code. There we can see it's a 200, so I was able to access it. And if we do the same with /admin, there you can see we get a 404 error because by default the admin page doesn't exist. But that's fine for now. So now we can configure our level 7 policy. So again, I'm going to paste it here. From a Kubernetes perspective, this is again a Cilium network policy. This time we deployed in the backend namespace because we want to configure our backend. Then we set it to all pods with the label app equals web. That's the one we have deployed before. And we allow the ingress from endpoints with the label app equals frontend and coming from the frontend namespace. So that's the container we configured for curl. Then we allow the traffic only on port 80 because that's the port our Nginx is listening. And here we have the special rule. Here we configure the HTTP method to get and the path to the root. This means we only allow get commands to the root path. So if you use something else, we should get an error message. Now let's apply this, and then we'll test if our policy is actually working. First, we're going to send again from the front end a curl request to our root folder, and we use get. So this is what we expect should work. And we can see we get HTTP 200, all works as expected. If we do the same with get, but this time to /admin, when we did it the first time, we got a 404 error because this page doesn't exist. And now we get a 403 because our policy blocks this request. So our request never reaches Nginx, and Nginx can't even serve the 404. We just get the 403 before. Lastly, if we do a post to the root folder, this should also fail because we configured only to allow get. If we execute this, we can see again, we have a 403, and with this, we see that we were able to completely lock down our Nginx, and we only allow what we want to allow, and everything else is blocked. So now with this done, let's take a look at our pod-to-pod traffic with the eBPF host routing. This means we're going to send traffic between the nodes, and then we see how much traffic we were able to send. So for this, I'm going to create a new cluster that doesn't have the network acceleration enabled. So I'm going to define a couple variables, name, location, and resource group, and then I'm going to create a new cluster. So that's a very basic one. As you can see, I only provide the name, the resource group. I use Azure as the network plugin, and I use the plugin mode overlay. I don't have Cilium, I don't have ACNS, so it's a very default cluster. And while this cluster is being created, now let's test our transfer rates on the cluster that had ACNS and the advanced networking enabled. First, I'm going to set up my server. So I'm using iPerf. So that's the server that's going to receive the traffic. And then we're also going to create a client. But since we want to send traffic over the network, this means between two nodes, I have to trick it a little bit. So we are going to use pod anti-affinity for our client. So we create here the pod. Then we have the pod anti-affinity, and we say we don't want to schedule it on a node that already has the server running. That's a way to make sure that we can schedule our pods where we want. In this case, we want it on a different node than our server. If you're interested in this pod affinity, anti-affinity, and how to schedule our pods, I will link a video down below where I can explain all of this. But for now, we're going to apply our client. Then we're going to check if our server and client are running. There you can see the server is running. Our client should also be running. It does. And now to just double check, we're going to do a kubectl get pods. And we also print on what nodes they're running. So here you can see we have our client that's running on a node that ends with the number 2. And our server is running on a node that ends with zeros. So this guarantees that we have our client and server on different nodes. This means we will send traffic over the network. And to do this, we can do just like kubectl exec in our client. Then we configure that we send traffic for 10 seconds. And in the end, we'll see how much traffic we sent. So I'm going to execute this. Now we have to wait 10 seconds, and then it will print out the entire result of data transferred and also transfer rate. And here you can see, we can see every second how much data we sent and overall. So overall we sent a little bit more, over 14 gigabytes, and the transfer rate was 12.1 gigabit per second. So this is almost the full physical capability of the network connection of our VMs. Also, what's important is that I don't have anything running on my cluster. So if you have a busy cluster, this rate might go down. But Microsoft says that with the ACNS and the advanced networking or accelerated networking enabled, you will see around 38% increase over a normal cluster. So by now, our normal cluster should be done. So let's switch over and we'll see what transfer rates we can achieve there. The cluster is created. Now I can download the credentials and can also access this cluster. Here we do the same what we did before. So we're going to create our eBPF server. Then we're going to deploy the same client again on a different node as our server. We're going to apply this. Then we check that server and client are running. So you can see here, both conditions are met. Then let's double check that they're actually running on different nodes. So we have here the number 1 and the number 0. So this means 2 different nodes. And now we can send the exact same request as before, which means again 10 seconds, as much traffic as possible, but this time we don't have the accelerated networking. This means that the transfer rate should be lower. And here you can see we have sent 11 gigabytes and we have a transfer rate of 9.48 gigabit per second. So that's quite a bit lower, especially if you have a lot of traffic that needs to be sent. And again, it's important that the clusters are basically running idle. So there's nothing else going on except my test. If you have a busy cluster, then your transfer rates might be even lower. And therefore with the accelerated networking might be even faster or faster compared to a non-accelerated cluster. All right, so that's great. The next thing I want to show you is the dashboard in Grafana and also what we can see thanks to Hubble and everything ACNS brings. To do this, let's switch over to the Azure portal and let's see what Azure created for us there. Here in the Azure portal, we can see that's our AKS cluster with ACNS enabled. If we scroll down a little bit, we can also see here that we have the Cilium data plane enabled. And now we can take a look at what dashboards Azure provides. This works because we created the cluster with the monitoring enabled. This means it automatically created a Prometheus instance that's collecting the data and also a Grafana dashboard that displays the data. If you remember at the beginning of the setup, we also configured the Prometheus config map, and this allows us to scrape data from Hubble. And now we should see this under the networking section. So here you can see under networking, we see some information like the bytes per node, the DNS errors, and down here we can also see packet drops and total flows by pod. These additional information, they all come from Hubble. So if you don't use ACNS, you don't see them. Here we also have a bit more packet drops, and here we can also see the cluster traffic for each namespace we have. Additionally, we can also just open a Grafana dashboard. So if you go to the dashboards, here the overview is not the best, but since it's for free, I don't think we can complain too much, but we can open the dashboards with Grafana. And now we can scroll down and search for it. I'm also quite zoomed in for the demo, so it makes it a little bit harder to see. But what we can search for now is networking. Here you can see all the networking dashboards. And we can take a look, for example, at the pod flows. Now let's see what we see here. So you can see the source and the destination namespaces, so you can see where our pods are communicating with each other. We can see the maximum amount of requests. It's not too much data we see since the cluster is fairly new. We can also see the outgoing traffic, the incoming traffic, the heat map, since I just created the cluster and also ran the test. It's obviously just happening, the requests. And here you can also see the outgoing and the incoming traffics and what pods. We could also see the drops. For example, if you have a lot of package drops, you should see some information there. And since it's Grafana, you can create all the dashboards you need, or you can also download the dashboards from Grafana. What I'm showing you right now is just what comes out of the box. It's free, so why not take a look at it and take use of it. Back in the terminal, I want to show you the last demo about pod-to-pod traffic encryption with mTLS. And to do this, I have to connect to the cluster we created with mTLS enabled. So just download the credentials. Then we're also going to create our frontend and backend namespace as before, and we're going to deploy 2 test applications. So one is a frontend with curl, also like before, so we can use it to send requests to our backend, and our backend is going to be Nginx, and it will receive requests. Then let's just check that our pods are running. So all pods, or both pods, are running. And then we can also take a look at our Cilium cTunnel. There you can see this has been deployed, and this is what we're going to use, or automatically use, for our mTLS encryption. So if you take a look at our pods, we have 3 pods running, and I have 3 nodes. This means we have 1 pod on each node running. So now let's enable mTLS, and all we have to do is set a label. So we do a kubectl for our entire frontend namespace, and the label is io.cilium/mtls enabled equals true. And now we have mTLS enabled for all our pods in the frontend namespace. But if you want to communicate with a different namespace, like in our case, we want to talk to the backend namespace, we also have to enable mTLS there. If it's only enabled on one namespace, then you won't have mTLS for the communication between the 2 namespaces. Then we can also take a look at all the namespaces that have this label. This means that have mTLS enabled. And here you can see it's the backend and the frontend. So that's what we just configured. If you now send a request from our frontend via curl to our backend, then we can see this works. We didn't get an error message, nothing extraordinary, no warnings. We just see the HTML of the Nginx starting page. And this is basically how mTLS works. It's like a lot of magic kind of, because you don't see it. You just know it's there once you've configured it, but it doesn't affect your applications. Since Cilium takes care of the mTLS and we don't have to configure anything, there's not really a way to check if it's actually enabled. But what we can do is we can use a tool called Spire to show us all the entries it has. And there we should see our frontend and our backend. So we do this with a kubectl exec. We go into the Spire server. That's the pod that's running and that's taking care of the encryption. And then we show all the entries we have there. And here we can see all the entries we have. And if we scroll up a bit, we should find our frontend and our backend. So here we have Kubernetes namespace frontend. We can also see it's using the default service account. That's the service account that's used for the encryption. It works. It's not the most safest implementation because every application should use their own service account, but that's a different topic. And if you scroll a little bit further up, we can also see here the backend. It's using the same service account, but it is both there. We can see an ID for the entry for SPIFE. That's again a tool used for the encryption. And we can see also here our cTunnel. That's the tool we have seen before. I know it's not that exciting, but here you can see we have the entry, and therefore we know that we have mTLS enabled. That's everything I want to show you today. So today we have seen that with the advanced networking with ACNS in AKS, that we have more possibilities than with just the basic Azure CNI powered by Cilium. It's still very complicated, but I think it offers a lot of exciting features. For example, we can control our egress. in our case, we saw that we only allowed traffic to github.com. We didn't have to use IP addresses. We could use the full qualified domain name. We could enable mTLS. This means we have encryption between our pods. We could see that the transfer rate between our nodes can be way higher. And we also saw that we get some observability with Grafana and Prometheus. The downside is that it's again another tool. It makes everything more complicated. You have to pay for it. It's not the most expensive tool, but again, extra costs. And so my recommendation would be to start without it, and only if you have the need for the features to enable it. I hope this was interesting. As I said before, we only scratched the surface, but I hope it gave you a good overview of the capabilities and it gets you started doing your own research, trying it out yourself. If you have any questions, let me know in the comments. If you like the video, please like it, share it, and I hope to see you next time with another video.